Your AITS done? Exam?
Yes, sir, but we haven't got the result yet.
You got the result?
No, sir.
How was the paper?
It went.
Okay. So this chapter is complete. Then we should start the fluids.
Yes, sir.
Solids.
Sir. Ah, yes.
Mechanical properties of fluids. Mechanical properties of fluids. In introduction, we have to know certain properties, like first property that we discussed. First, you remember fluids, if I am saying, it is something that can flow. So something that can flow means it will also contain liquids and also gases. Liquids and gases both you can write as a fluids. One property is we call as density. Density we write as the mass per unit volume. Mass by volume. We can say this is the density is mass by volume. If you want to find relative density, then it is basically density of a body divided by density of water. Understood, Neil?
Yes, sir.
That means relative density is equal density of the body divided by density of water. Normally, density of water is 1 gram per centimeter cube in CGS system. In SI system, you can write 1000 kilogram per meter. This value is in CGS. This value is in SI. Understood?
Yes, sir.
Okay. I have written.
I'm on the last statement.
Okay. If you have a mixture, that means two liquid we have mixed or two gases you have mixed. In that case, if you want to find the density of the mixture, then it should be like total mass of the mixture, total mass कौन लेके बीच में बैठा ना टाइट से पकड़े total mass divided by total volume. If I say there are two liquids or two gases in the mixture, then you can say it is M1 plus M2 divided by total volume V1 plus V2. Sometimes mass is not given. So M in place of M1, you can write here rho 1 V1. That is for mass of first liquid, and second rho 2 V2 mass of second liquid divided by V1 plus V2. Let's suppose mass is given, volume is not given. So we'll take M1 plus M2. Instead of volume, हम लिख सकते हैं मास बाय डेंसिटी. फॉर पहले गैस लिक्विड्स के लिए m1 by ρ1 and for second we can write m2 by ρ2. So these all three formulas you can use for the mixture. You can use total mass by total volume if both are given. If density and volume are given, then you can use this formula. If density and masses, individual masses are given, you can use this formula. Understood, Neil?
Yes, sir.
Then next property that you should understand is pressure. Pressure. Pressure is what? It is the force divided by area. But which component of force will take? That component which is perpendicular to area. That means F perpendicular means what? Perpendicular component of force. Perpendicular component of force. Like if I say one surface is given, and you are applying a force like this. So at some angle it is given. Let's suppose some angle, this angle is given theta. This angle is also theta. So if this force is F, then this force will be F cos theta, and this force will be F sin theta. सो इसमें F sin थीटा प्रेशर नहीं लगा पाएगा क्योंकि ये टेंजेंशियल फोर्स है. आपको वो फोर्स लेना है, वो कंपोनेंट लेना है जो एरिया पे परपेंडिकुलर हो. वो वाला कंपोनेंट हमारा ये है, F cos थीटा है. ये में दिख रहा है कि ये एरिया पे परपेंडिकुलर है. यानी यहाँ पे अगर हमें प्रेशर निकालना है इस कंडीशन में, तो फॉर्मूला दैट वी शुड राइट इज F cos थीटा डिवाइडेड बाय एरिया. ठीक है नील, समझ में आया बाबू?
Yes, sir.
गुड. प्रेशर is a very important property because liquids and gases both exert pressure on the container. So let's understand how much, what is the formula and what are the important properties of the pressure. Let's first we discuss pressure exerted pressure exerted by, fluid. This concept we discuss in two parts. First, on the base of the container, and other second we'll discuss on the side wall of the container. First, we discuss on the base of the container. Base of a container. So let's suppose I have a container, and in this one liquid is there. You can take the area also here. So area, this is the area here. Let's suppose this is the liquid that we have kept, and the height of the liquid is given h, and it is actually applying some pressure on the base, here. Okay, this area here I am writing as A. Okay, this area of the base I am writing as A. And how much force will be applied? Definitely, what is the weight of the liquid? That much, that only the force will be applied. And the weight is perpendicular. So I can say that pressure on the base. Also, there is an atmospheric pressure. Atmospheric pressure is P naught. It is here also. And here at the base, pressure will be, first will be pressure atmospheric, and then it will be also pressure applied by the liquid. Both two types of pressure will be there. So here pressure at the base will be atmospheric pressure. This P naught I am writing as atmospheric pressure. Atmospheric pressure. Atmospheric pressure. So P naught plus pressure applied by the liquid. So I can write here, this is P naught. Pressure formula is what? Force divided by area. And I told you that force is the weight of the liquid. So weight by area. Or we can write weight is equals to mass mg by area. So I can say it is mass is, you can write density into volume. Volume is always area into height. Area into height. That is the volume into G by area. So area cancel. So pressure at the base is P atmospheric divided by rho G H. That is the pressure at the base. Pressure at the base, I have got P naught, that is atmospheric, plus rho is the density of the liquid, G, and H is the height of the or depth of the liquid. This is called absolute pressure. Called absolute pressure. Understood, Neil?
Yes, sir. Understood.
Please copy it.
Yes, sir. Done.
Okay. So here, this part, rho GH, is the pressure due to liquid or due to fluid. So if I say that pressure at the base, pressure at the base due to fluids only. Atmospheric I am not considering, due to fluids only. Then you will write rho g h. This is called gauge pressure. So two type of pressure. Gauge pressure is only pressure applied by the fluids, and absolute pressure, that is a total pressure where you have to add the atmospheric also. Okay, understood?
Understood.
So what you can see that the pressure is directly proportional to depth. That means pressure increases with depth. Pressure increases with depth. Pressure increases with depth, and it increases linearly. You can see it increases linearly. Why? Because a straight line equation, P at the base is P naught plus rho G H. That is the pressure at the base. Now, if you differentiate, then we can say here dP will be rho G dH. That means the dP by dH. So pressure, depth, slope, if you find it is constant, it is rho into G. Like that we can write. One more thing you should understand. Okay, this we have discussed that pressure at the base, how to find. Now let's understand pressure on the side wall. Pressure on the side walls of a container. Pressure on the side wall of a container. Let's suppose I have taken one liquid in a container whose side wall I'll make one side for explanation. Let's suppose this is the side wall. Side wall width I am writing as B, and you have filled some liquid up to some height h. Let's suppose this height you can take as h. The density of the liquid is rho. Now here if you see at this point, pressure is only P naught. But here if you see the pressure at this point pressure is P naught plus rho G H. So pressure is not constant. When you go down, the force increases, the pressure also increases. And the pressure becomes maximum when you go at the depth here. So pressure is increasing. So we cannot take one value of pressure and area. We cannot take like that. So we discuss here average pressure, because pressure is increasing linear. Whenever things increases linearly, you can take the average. Average pressure on side wall. Side wall. So it will be, if I take this pressure here is P1, and at the bottom we can take P2. So average value is always P1 plus P2 by 2. P1 is here P naught, and P2 is P naught plus rho GH divided by 2. So it is basically 2 P naught plus rho GH by 2. If you take the average separately, right, then you find that P average equals to P naught plus rho GH by 2. This is the average pressure. If you try to find the average force on the side wall, average force on side wall. So that is P average pressure multiplied by the area of the side wall. Area of the side wall will be B into this is H. Height is H only, both sides. This height is H. So we can say it is average force. If I have to find, it is P naught plus rho GH by 2 multiplied by area is called B into H. Now this I have found is absolute pressure. That is atmospheric pressure also I have considered. Okay.
Okay, sir. Just one second. Just one second.
Yeah, yeah, okay.
Yes, sir. Done.
Okay. If I say the average pressure that only liquid has applied on the side wall and not consider the atmospheric. So average pressure by that fluid on the side wall. On the side wall. So this we can write only this part. Only this part. This will be rho G H by 2. And you can also write average force by fluid on side wall. Then you can multiply with the area, that is rho g h by 2 multiplied by b into h. So its formula is rho g b into h square divided by 2. These two lines also you write, Neil.
Okay, sir. Done, sir. Yes, sir. Done.
Okay. Now property you also understand that first is pressure by fluid on the base is independent of shape of the container. It does not depend upon the shape of the container. It means that if I have one container in this shape, I have one container in this shape, I have one container, let me be in this shape, or I have some irregular shape container like this. In all container, I have filled the same liquid up to same height. Density should be same and height is also same. So if this is rho and this height is h, so pressure at A, pressure at B, pressure at C, pressure at D, all going to be equal. Pressure at A is equal to pressure at B is equal to pressure at C is equal to pressure at D, and that is equal to rho G H. Understood, Neil?
Yes, sir.
So
Understood.
it does not depend upon the shape of the container. Please write this also. This type of Uh, Next property says that pressure at same horizontal level will be same. Pressure at same horizontal level will be also same. It means that if I have one container that I am making like this, and some liquid we have filled. Okay, here we can say if container has no acceleration, it should not move with any kind of acceleration. So point number 1A, point here B, or we can take point at C. You see that point A has different amount of liquid, height is different here. Point at B here, height is different, liquid height is different. At C also, liquid height is different. Okay, so if you see the formula rho gh, it might appear that the pressure will be different, but they are at the same horizontal level. So I told you that at same horizontal level, pressure will be equal. PA will be equal to PB is equal to PC. Why? Because the container here will apply, if the height is less, the container will apply some force, normal force, and due to that force, it will have same pressure. Otherwise, if the pressure will not be same nil, then liquid flows from high pressure to low pressure. So liquid will start flowing inside the container itself. But we don't see the liquid flowing inside a container if it is kept on a ground, right?
Right, right, right.
Yeah, that's why pressure at the same horizontal level should always be same.
Okay, sir.
Okay. We have a law here that is Pascal's law. Pascal's law. It states that if pressure is changed, if pressure is changed at any parts, at any part of a fluid, then the change in pressure the change in pressure is transmitted is transmitted to all parts of the fluid. To all parts of the fluid without getting diminished. Without getting diminished. This is a very important uh, law that says that the if I change pressure at any part, then that change in pressure will be transmitted everywhere in the fluid, and its value will not decrease. Without getting diminished, it will flow. I'll explain it with example, but first you write this statement. Tell me that you have written.
Yes, sir.
Now, let's understand this with an example and its application. Suppose I have uh, one container, and this container I have fitted with some piston here. Here is one piston here, and this piston has some area A. Now I'll take one piston here. Let's suppose this piston has a area A by 2. I'll take one piston here. This has area, let's suppose 3A by 2. And I'll take one large piston here. Let's suppose here area is 2. And I have filled one liquid here in the container. Let's suppose. And what I'm doing, I am applying force F here. In this piston, I am pressing with the force F. So how much force we are applying here? We are applying force here, or how much pressure we are changing here. So we are changing the pressure delta P is equal to F by A. Why I'm saying that change in pressure? Because the pressure already atmospheric is there. So if you apply some force, you add some more pressure. So that pressure we call as change in pressure. So this change in pressure will be all parts it will be transmitted. That means here also the pressure should be how much? F by A. But here area is A by 2. To make the pressure same, here the liquid will apply how much force? It will apply F by 2. So that if you divide here also, change in pressure will be F by A. Here area is 3A by 2. So here the liquid will apply how much force? 3F by 2. If you divide, then here also pressure is same. Without getting diminished, same pressure is moving to all parts of the liquid. and here it should be 2f because area is 2a. So here also delta p will be equal to, this is f by a. So what you can see that, you can see that any change in pressure is transmitted, any change in pressure is transmitted to all parts of the, all parts of the fluid. Understood, Neil?
Yes, sir. Understood.
Yeah, please make.
Yes, sir. Done.
Okay. There is one good application of this law that we call as hydraulic lift. A hydraulic lift. Hydraulic lift is something, hydro means water we are using. It is used in car garage. When you go to the car garage, then they lift the car, very heavy car, with very easily they lift with this concept, this principle, Pascal's law. They have two platforms here, have different area of cross section. Its area is small, its area is big, and it has been filled with water. It is filled with water. So we apply force on the smaller area, F1, and here we keep the car. So that means how much pressure we are changing here? We are changing pressure here, F1 by A1. Here area is different, so here force will be different. So here F2 force liquid will apply on the car. So here this is delta F, oh sorry, delta P will be F2 by A2. Pascal says that same pressure will move here and there. That means delta P here both are same. So we can write here F1 by A1 is equals to F2 by A2. That means that F2 that liquid will apply on the car is basically F1 multiplied by A2 by A1. So if I say that A2 is far, far greater than A1, then you can see that F2 is far, far greater than, this fraction will be also greater. Then F2 will be also far, far greater than F. That means with small f, with a small force applied, with a small force F1, a big car can be, or big lift, big material can be lifted. Heavy weight can be, heavy weight can be lifted by F2 because F2 will be in, F2 will be increased. Understood this concept, Neil?
Yes, sir. Understood.
Yeah.
Yes, sir. Done.
Okay. So hydraulic lift can be considered as an application of Pascal's law. Now let's discuss one example based on this pressure concept that we have discussed. Say I have a tube like this, and here I have make some plug there. This side I have kept a liquid on this arm. This density is, let's suppose, 3 rho, and this side I have kept another liquid of density rho, and I have kept them at the same height, same depth h by this plug. If plug I remove, then if this plug I remove, then the heavier liquid will come down and the lower will go up. So level will not remain same. Right now, level is same only. Okay. So if my question is, if plug is removed, if plug is removed, then what will be? the level of liquids in both arms, left arm and right arm, both arms. What will be the level of liquid in both arms? So let's suppose if you remove this plug, if I remove this plug, it means that the heavier will go down, the lower will go up. Say heavier has come here, this much down it has come. Let's suppose up to here it has come. So this much down it has come. So same, this will go up. This will also, let's suppose this has gone at a down x. So this will go up by x. Now the concept we discussed that pressure at the same level is always equal. So if I take here one point, this B, one point A and B I have taken at the same horizontal level. So I can say that PA is equal to PB. Why so? Because they are at same horizontal. Now the new level of this liquid is this much only because it has come down. So this will be H minus X. Whereas this row has gone up to here. So its level will be now H plus X. So pressure at A will be atmospheric pressure plus density is 3 rho into G, and height is H minus X. Whereas at B also atmospheric is there. This side density is rho G, and now the height has become H and increased by X. So H plus X. P naught cancel. So I am getting here 3 rho G H minus X is equals to rho G H plus X. Rho G cancel. So that is 3H minus 3X is equal to H plus X. So I can take here 3H minus H is equal to X plus 3X. That means 2H is equals to 4X. It gives H is X equals to 2H by 4, basically H by 2. That means on this side, left arm, it will be H minus, here will be H minus H by 2. And on the right side, H plus X actually becomes H plus H by 2. So I can write that the level on left arm is equal to H minus H by 2. H minus H by 2, that is H by 2 itself. And level on right arm, it will be H plus H by 2. That is 3H by. Understood, Neil?
Yes, sir, understood. Just one second.
Yes, please.
Yes, sir, done.
Okay, so pressure concept we have discussed when the container is kept at rest. What is the pressure on the base? What is the pressure on the side wall? application of Pascal's law. These all are the conditions where the container is at rest. Now in next class, we'll discuss pressure when the container is moving with some acceleration. That condition we'll discuss in the next class. Okay, Neil?
Okay, sir.
Okay, good day. Bye.
Thank you, sir. Bye.